Hello friends, today we're going to be talking about polygons and specifically angles in polygons. So we're going to have the name polygons, find sums of interior angles, and find values of interior and exterior angles. Our state standard, use properties of polygons. Polygons is there twice, to define them, classify them, solve problems, and logically justify results. So what is a polygon? Here are some examples of polygons. Here are some examples of shapes that are not polygons. Our definition of a polygon, a closed shape, so it can't have any gaps, with straight lines and angles. So if there's any curves, it's not a polygon. The word poly comes from the Greek meaning many and angles. So polygon means many angles. Has to have straight lines, closed, angles, more than two sides, and no curves. So if we look here, these all have curves, which is why they are not a polygon. Has to have straight sides. Here are the types of polygons. You already have this on your note sheet, but these are the names of them. So we're going to name these polygons. To name them, we have to count the sides. So this one has 1, 2, 3, 4, 5, 6, 7 sides. So if it has 7 sides, it's called a heptagon. Hepta means 7. This one has 1, 2, 3, 4, 5, 6, 7, 8 sides. So it's called the octagon. 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is also an octagon. This star, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So it's called a decagon. Deca, like a decade, is 10 years. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So this one is also a decagon. And then our last one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If you notice there, we don't have any specific names for anything above 12. We just call it an n-gon. So this one, since n is the number of sides, there's 16 sides, we would call this a 16-gon. So if it has over 12 sides, just however many sides it has, it's that gon. All right, with polygons, we have interior angles and exterior angles. Interior is obviously inside the shape. Exterior is on the outside of the shape. So if we take any polygon and kind of extend its side, the angle that it creates on the outside is called the exterior angle. So let's figure out where the formula comes from. We're going to figure out how many triangles there are in each of these shapes. This first shape has 5 sides. It's a pentagon. And if I take any vertex, I'll just take A here, or take any angle and connect it to the angles it's not connected to yet. I notice that I have 3 triangles. My next shape has 6 sides. And again, I'm just going to choose one of the angles and connect it to the other angles that it's not connected to yet. And this makes 4 triangles. So there's 5 sides, 3 triangles, 6 sides, 4 triangles. This next one has 7 sides. So let's see how many triangles this one makes. Maybe you're starting to notice the pattern. When we have 7 sides, we have 1, 2, 3, 4, 5 triangles. And then finally, this next one has 8 sides. If I make my triangles here, there's 1 triangle, 2 triangles, 3 triangles, 4 triangles, 5 triangles, and 6 triangles. So if you notice here, the number of triangles is always 2 less than the number of sides. We know that triangles add up to 180 degrees. So if I wanted to find how many degrees were in this pentagon, there's 3 triangles times 180 degrees. For this hexagon, there's 4 triangles times 180 degrees. 5 triangles times 180 degrees. 6 triangles times 180 degrees. So our formula, n minus 2, so n is the number of sides, times 180. If I want to know how much one angle is, I would divide by the number of sides. That's only if all the angles are the same. So let's look here. Our first one, if we count the sides, there's 9 total sides. So the total sum then, I would do 9 minus 2 times 180, or 7 times 180, and I would get a total of 1,260 degrees. Don't forget the degree symbol. And if I just want to know one of the angles, I'm going to do 1,260 divided by the number of sides, which is 9, and I would get each angle is 140 degrees. So each of these angles is 140 degrees all the way around. So look at this next one. If I counted the number of sides, there would be 12. So 12 minus 2 times 180 gives me 1,800 degrees. Measure of each angle then, I'll do 1,800 divided by 12 because that's how many angles there are, and each angle would be 150 degrees. This next one has 7 sides. So 7 minus 2 times 180 gives us 900 degrees. And if I did 900 degrees, or 900 divided by the number of sides, which is 7, I would get approximately 128.6 degrees. Well, let's look at this one. I see it has 5 sides. So the sum, or the total, would be 5 minus 3 times 180. Sorry, not 5 minus 3. 5 minus 2 times 180, which would give me 540. So I know all of those added together gives me 540. So 85 plus 103 plus 121 plus 68 plus x gives me 540. If I added all those numbers together, I would get 377. So 377 plus x is 540. And then taking 377 from each side, I would get that x is 163 degrees. Again, do not forget the degrees symbol. Let's look at one more like this. Again, we have a pentagon here. So we just figured out that the sum, or if we add all the angles together, it would be 540 degrees. So adding all these, 91 plus 125 plus 92 plus 3x take away 5 plus 4x take away 8 is going to be 540. Now combining like terms, 91 plus 125 plus 92 minus 5 minus 8 is going to give me 295. So again, that's all of the constants. And then if I look at my x's, 3x and 4x is 7x. So this would end up being 295 plus 7x equals 540. So taking 295 from each side, I would get that 7x is 245. And then dividing by 7, I would get that x is 35. Exterior angles of a polygon. The sum of the exterior angles of a polygon is always 360. So it doesn't matter how many angles it has. If we look at just the exterior angles, which again, to find the exterior angles, we just take any side and extend it. So if I extend each of these sides, I get the angles A, B, C, D, and E. And if we added up A plus B plus C plus D plus E, I would get 360 degrees. If we have a regular polygon, which means that all of the sides and angles are the same, we can just take 360 divided by the number of sides. So here my number of sides is 5. So if I do 360 divided by 5, I would get that each exterior angle is 72 degrees. So again, what that means is if I extended each of these sides, the angles they created would be 72 degrees. All right, let's look at our next one here. Looks like this has 8 sides. So 360 divided by 8 is 45 degrees. So again, I'm not going to do it for all of them, but each of these, if I created exterior angles, would be 45 degrees. Let's look at these ones. So here they're saying angles 1 and 3 are the same. And they're saying angle 1 is 3x, which means angle 3 is also 3x. They're telling me angle 2 is 2x. And then angles 4 and 5 are both 90 degrees. So I know all of them together have to be equal to 360 degrees. So I'm going to say 90 plus 90 plus 3x plus 2x plus 3x, so those are all 5 angles, is going to be equal to 360. Combining like terms, 90 and 90 is 180. 3x and 2x and 3x is 8x. And then solving here, we'll take 180 from both sides. So 8x is 180. And then dividing both sides by 8, we'll get x is 22.5. But they're asking us what the measure of each angle is. So we need to write down the measures of each of these angles. The measure of angle 1 then is 3x, so 3 times 22.5. And remember, that's also angle 3 as well. That gives us 67.5 degrees. Measure of angle 2 is 2x, so 2 times 22.5, which is 45 degrees. Again, we found that the measure of angle 3 is the same as measure of angle 1, so 67.5. And we already know that the measures of angles 4 and 5 are 90 degrees. I can double check by adding all these together. And if I added 67.5, 45, 67.5, 90, and 90, I would get 360, which is what I'm supposed to get. All right, friends, that's all I have for you today. Have a good day.